Hello everyone, welcome to my YouTube channel. Hi, this is Nipur. I passed out from IIT Dhanbad. I already qualified Iit-Jee, GATE, just IIT Jam Physics, right? So today we are going to solve SC Verma, all the solved example of a Bundy motion in a straight line, right? In the previous video, I completed important points to remember from the NCERT book, right? So today I solved all the solved example of a SCV book, right, from a Bundy motion in a straight line, right? It is quite useful for you, and I hope that your preparation is going very well and you feel very good. And if you have any like suggestion for me, or like any topic you want, I make the videos, right? So shall I proceed for this question? Right. Okay. Just an old person moves on a semicircular track of a radius 40 meters during a morning walk. If he starts at one end of the track and reaches the other end, find the distance covered and the displacement of the person. Right. So in this question, what they are telling that a moves moves a semicircular track like this. Just 1 minute. A person moves a semicircular track. Just 1 minute. Okay. Semicircular track, right? And this semicircular track has a radius is how much? 40 meter, right? If he starts at one end of the track and reaches the other end, means like someone starts from this end, a point, and reaches the other end, find the distance covered and the displacement covered. So distance, you know, that is the distance is basically pi r, right? So pi r is basically, you know, pi r value is basically 3.14, and radius is 40 meter, right? If you multiply this, what you are getting? 3.14 into 40, that is 125.6 meter, the distance they cover. And displacement, you know, displacement is basically shortest distance between the 2 points. Shortest distance between the 2 points means I have to go A to B, so I cover this point to this point, and that is basically 2r. So displacement is basically 2r, and 2 into radius is 40, so displacement is basically 80 meter, right? You understand now? So shall I proceed for the next question? Yeah. Now the next question is, the distance traveled by a particle in time t is given by this. Find the average speed of the particle during the time and the instantaneous speed, right? So in this what they are asking, average speed. So average speed, you know, that is basically total distance upon total time, right? So average speed is basically total distance. So total distance in, that is they have given 2.5 meter per second square t square at t is equal to 5 to 0 second, 0 second, right? And total time is 5 minus 0. So average speed is basically 2.5 into 5 square divided by 5. So if I 5 to 5 cancel, so that become 2.5 into 5, that comes out to be 12.5 meter per second. 12.5 meter per, sorry, 12.5 meter per second, right? So and now what they're asking, the instantaneous speed. First you have to differentiate. We know instantaneous, what we do differentiation with respect to time, right? So dy by dt, that they have given 2.5 t square. So if you do differentiation, we know dy by dx x ki power n, that is equal to nx ki power n minus 1. So that comes out to be 2, that comes out to be 2.5 into 2 t at t is equal to 5 second. So average speed is comes out to be 5 t at t is equal to 5. So 25 meter per second, that is our average speed, right? So this is our average speed, right? So shall I proceed for the next question? Yeah. So the next question is, in the figures on the position, just a minute, the position shows the speed versus time graph for a particle. Find the distance traveled by the particle during the time t equal to 0 to t is equal to 3 seconds. They are asking the particle, what is the distance traveled? As we know that in position time graph, if you find slope, that gives you the velocity, right? And in velocity time graph, if you find slope, that gives you acceleration. And if you find area, that gives you change in that gives you change in displacement displacement or distance. Or acceleration time graph, if you find area, that gives you change in velocity or speed, right? So now you see this is velocity time graph and they are asking distance covered. Distance means you find just area, and this is a triangle, so you can directly find area and you got the distance covered, right? So we want distance. So this is area of triangle 1 upon 2, base is 3, height is 6. So that comes out to be 3. So distance covered is basically 9 meters. Understand? A table clock has its minute hand 4 centimeter long. Find the average velocity of the tip of the minute hand. Means their minute hand is 4 centimeter long. Means their radius they have given 4 centimeter, right? Find the average velocity of the tip of the minute hand. Like it is like this. Suppose this is our hand, like like at the time 6 p.m. is going to happen, 6 a.m. is going to happen. So our minute hand and this is our hour hand, right? So 6 a.m. this is going to happen like this, right? So if 6 a.m. to 6:30 a.m. is going to happen, this minute hand is rotated by 180 degree, right? So minute hand rotated by like 30 degree means 30 degree rotated by so they come 6:30 means 30 minutes they have to travel, so they rotated by 180 degree. Means in this condition the displacement is basically 2r. Basically this is 2r means 8 centimeter, right? Now what they're asking, the average velocity between 6 a.m. to 6:30 a.m. means in 30 minutes how many seconds are there? 30 into 60, that is 1800 seconds. So average velocity is basically change in displacement basically 8 centimeter and upon time interval is basically 800. So if you solve this, so you get the answer is roughly 4.4 into 10 to the power minus 3 centimeter per second. Now our next, this is our first question, right? This is our first, and now our second question is find the average velocity of the tip of the minute hand between 6 to 6:30 a.m. and between 6 a.m. to 6:30 a.m. 6 a.m. to 6:30 p.m. means 12 hours 30 minutes. Means they in 12 hours 60 minutes how much second is going to happen? 12 hour into 60 minute into 60 second plus 30 minute into 60 second. So that comes out to be 12 into 60 into 60. So 43,200 plus 30 into 60. So that is just 1 minute. 30 into 60, that is comes out to be 1800. So this comes out to be 4500 second. So now we have to find average velocity. So average velocity is basically change in displacement basically 8 centimeter upon time is 4500 seconds. So this comes out to be 1.8 into 10 to the power minus 4 centimeter per second, right? You understand now? So shall I proceed for the next question? Right. So this question particle starts with an initial velocity, means they have given initial velocity is 2.5 meter per second along the position of a x direction, right? And they have uniformly accelerated by 0.5 means 1 by 2 meter per second square, right? So you can also this is quite easier, like without point, this is 5 by 2 meter per second. Acceleration is 1 by 2 meter per second. Find the distance traveled by it in first 2 seconds, means first 2 second distance traveled is s is equal to ut plus half s is equal to ut plus half at square. So distance traveled in first 2 seconds is basically 5 by 2 into 2 plus half 1 by 2 and t is 2 square. So that comes out to be here 2, so 2 cancel, here 2 2, this is cancelled. First 2 seconds they cover a distance of 6 meter, right? Now second question, what they are telling that how much time does it take to reach the velocity, means their final velocity becomes 7.5 meter per second. For this, how much time they are take, right? So we know v is equal to u plus at. Final velocity is 7.5, initial velocity is 5 by 2 means 2.5 plus acceleration is 1 by 2 t. So this comes out to be 5 is equal to t by 2, means they take 10 second 10 second to reach this. Now third C part is how much distance will it cover in reaching the velocity, and like when their final velocity becomes 7.5 meter per second, how much distance they cover it, right? So we know v square, we can also find but v square is equal to u square plus 2as. The final velocity is 7.5 square plus initial speed is 2.5 square plus 2 times acceleration is 1 by 2, distance is s. So 7.5, if you cancel this point, so here comes 10, here also come 10, so this become 15 by 2 whole square minus 5 by 2 whole square is equal to, this is 2 so 2 cancel, that is s. So this is 2 2 is 4, so 5 5 is 15, 225 minus 25 is equal to s. So s comes out to be 200 divided by 4, so s comes out to be 50 meter. S comes out to be 50 meter. S comes out to be 50 meter. Right? A particle with having an initial velocity u moves with a constant acceleration a for a time t. Right? Suppose particle has, like this is a particle that has an initial velocity u, moves with a constant acceleration. Acceleration is constant for a time t. Right? Find the displacement cover. Find the displacement cover in displacement of a particle in the last 1 second. Means last 1 second means distance traveled in t second and distance covered in as t minus second. You have to find this. So this we got the distance displacement in the last t second, and we know this. This is, you can directly know distance traveled in ns second is u plus a by 2 2n minus 1. This you can directly remember. This is a standard, right? Also, or otherwise you can do also in this way, just us is equal to ut plus half at square minus distance doubled in t minus 1 u t minus 1 plus half a t minus 1 whole square. If you do this thing, if you subtract this and solve this thing, so s comes out to be u 1 second plus a by 2 2t minus 1. This equation comes, right? And I directly write down this, so you can remember this. And then after that they have said that if they give the all the value of it, like u they have given 5, so we directly put it, right? So we directly put it, u is equal to s is equal to u is 5 plus acceleration is 2 by 2 into 2, t is 10 minus 1. So s comes out to be 5 plus 5 2s are 20, 20 minus 1 19. So that comes out to be 24 meter. Now next I proceed for a next question. Right. This question we have already done by mistake. The last question of our solved example of a SCB. Right. From a 1D motion in a straight line. A ball is thrown up at a speed of, it is like this. I just should draw the diagram. A ball is thrown up with the speed of 4 meter per second. Find the maximum height reached by the body is. Just a minute. Maximum height reached by this body is h max we have to find, right? And we know that h maximum, their final velocity is 0. When we are throwing the ball, that has minus g. So we can directly apply v square is equal to u square plus 2as. Right? The final velocity is 0. Initial velocity we find plus 2 times. Acceleration is minus g. Distance is h max. So h max is comes out to be u square upon 2g. And they have given u is 4 divided by 2 into 10. So h max is comes out to be 4 4 is 16 by 20, 4 by 5. So h max is comes out to be 0.8 meter. 0.8 meter. Right? So this is our last example. Right? Next solved example of a SCV problem from motion in a plane. Right? So these are the only solved example of a SCV book, like 1D motion in a straight line. Right? I hope you understand this concept. And the next video I solved all other problem like exercise problem also and other solved example. Right? I hope you feel good and you feel really amazing to see these videos. If you feel these are videos are really helpful for other people also, you can share in other group or other people with also, so that they can feel and they can also suggest me whatever the content they wanted. Thank you.